Okay, I'm gonna share the screen. All right, so let's go over the problems. Let's go to GitHub, sorry, Brightspace for that. So this is Brightspace. We're currently on the RSA module, if you remember. And I have a Word document here. It's got 3 problems, basically. Okay. So these are the 3 problems. You know, I will do number 1. This is kind of the toy example that I did in lecture on Tuesday. Then you have to do problem 2, which is basically just using the code from problem 1 and repeating with these variables. So I've given you variables, and you should know by now how to compute the other ones that you need. Okay. And then problem 3 we will do next Thursday, because this is much more complicated. Okay, it's a different so this is like a toy one. This is real RSA implementation. So there's a lot of little details to be addressed. Okay. All right, so let's read through the problem. And this is really what we had talked about, right? So Bob wants, so this is RSA. And remember, we're using RSA to send the secret key for our symmetric key encryption technique like AES or DES. So Bob wants to communicate with Alice. He wants to send her a message M. Bob knows the public key of Alice, which is N, E, or E, N, right? Now Bob encrypts the message using Alice's public key. Bob converts this message into a number M, so that's the number. Using the number M, Bob now creates the ciphertext C using the following equations. So we went over this in lecture on Tuesday, right? And so today we're going to implement it in Python and basically get a feel for that. Now Bob transmits the ciphertext C to Alice. Alice receives the ciphertext C from Bob. Alice uses her private key to decrypt the ciphertext to get the original text. This is done using the equation given below, which should look familiar to you as well, where D is the private key of Alice and E is the public key. Now, remember, as I've stated it here, really I should have said the exponents, because the public and private key are made up of public is E, N, private is D, N. And we will see this when we use OpenSSL. We're going to look at the files themselves to find the variables, but that'll be in a later lecture or whatever. The letter N is the product. So remember, the letter N is the product of P and Q and is stated by that formula, which are randomly and independently selected large prime numbers such that P and Q are different. So assuming that M is 7, P is equal to 5, and Q is equal to 3, and that the keys are E equal 3 and D equal 3, and N you need to calculate. Calculate the value of C. Write a Python program to demonstrate this. Remember, this has this is how did I put it? There's a error here or a bad implementation, right? Can you spot it? We did this on Tuesday, right? What's the problem with this? In problem 1, what's the problem? There's something that's not secure, if you will. How about that? Yeah. They're both 3, right? And this was exactly the thing we did on Tuesday. So don't forget that would make it insecure. They can't be the same. Now, in number 2, this is the more correct way of doing it, but I will leave that to you guys. It should be pretty easy. Using the code from problem 1, encrypt M equals 65 and calculate the cipher C. Assume the public key is 17, P is 61, Q is 53, and D is 2753, right? So those are really large numbers. So you may have a challenge there to do that. And it kind of illustrates why we need something like very powerful libraries to be able to do these things correctly. Okay. Got it? All right. So let's go ahead, first of all, and let's implement the code. So I'm going to switch over to the virtual machine. And this is just a simple example, just to kind of illustrate some things. Okay. So I'm going to go to the desktop. ITS 350. And this is RSA. So let me create a new directory. Okay. So let's CD into RSA. And all right. So we're going to create our first RSA code, right? Just to kind of implement these. So let's do, I'm going to do nano. I'm going to call this one. This is actually not even, I'm just going to call it RSA modulus. And it's basically, that's the operation that we're learning right now, right? So the mod. So RSA mod, just to let you have an intuition for it. Why? RSA mod.py. Okay. All right. We don't really need any libraries for this one. We're going to define our functions. Encrypt. And I will say encrypt RSA toy, just to kind of illustrate. It's not it's not complete. Okay. And I'm gonna do 1, 2, 3, 4. Return. I'm gonna add a line here. I'm gonna do decrypt RSA toy. Okay. And 1, 2, 3, 4. Return. Right. And it's that simple. So we're going to define the functions, but before, let's do the main. Let's just like do this. So M is 7, right? I believe. Later on in problem 3, we will actually be able to have a string, like actual text, and do that with text. But here I'm just doing it at the number level. So we want to get into the habit of defining our parameters, our letters. So for this problem, P was what? What was P? You guys remember? P was 5 and Q is 3, right? Q is 3. So these are the prime numbers we will actually have in problem 4, if you've ever wondered, the actual code on how to create prime numbers. So from scratch. So that'd be kind of nice, right? So there's an algorithm for that, right? So we'll be able to generate, reasonably large prime numbers. But here, let's just hard code them. So what do we need? N, right? So that's just P times Q. Oops, sorry. Times Q. That's N. Now we can proceed. So we would have cipher equal encrypt RSA toy. Oops. Toy. All right, and this should take some parameters. And then we can print cipher. And then now we're going to decrypt it, right? So we're going to say decrypted, what do you want to call it? Plain, right? And then this is going to be decrypt RSA boy, right? And then we're going to print out decrypt. So decrypted Okay. All right, so now before we put in the parameters, let's go into the function so that we know exactly what it is that we need to provide. So we're going to say, let's go to encrypt actually. So in the handout, it says that to encrypt, we need m to the e mod n. Remember? So we went over already on Tuesday what mod does. Here we're just going to use it in Python and hard code it. So let's go back to here. So now I'm going to create some variable. You can call it v, something like that. And then what we have here is what? We have the, let's call it what? The message, right? Which in this case is just a number to the power. So there's a couple of ways of raising something to the power of something. There's a Python function called POW, P-O-W. We'll use that in problem 3, but we can also do this. And that's to the E, right? So to the E. And then I did it in parentheses just to kind of show it. And then modulus, the mod is basically that we showed a percentage in Python. Okay. And then we plug in the last variable, which should be n. Do you guys see that? Make sense? So then we want to return v, basically, and that's our cipher. So yeah.
Are those two asterisks?
Yeah, they're two asterisks.
Oh.
It's a way of writing in Python. Yeah, X to the what? Oh, is it? Okay. Yeah, sorry. Let me see if I can make this bigger. I think here. All right. So let's now, so that's the encryption, right? Now, so that means we need to provide these messages. So that's message, comma, E, comma, N, correct? These are parameters that we would have. Right? Oh, yeah, sorry. Okay, now let's think about decrypt. So decrypt, let's just use like D, or actually that'll be confusing. Let's use K. All right, so we can look at the Word document, and we saw that for the document, C to the D mod N gives us M, okay? And that's the definition of RSA, so we can implement that in code. Let's go. We're going to say, I'll use parentheses again. This time it would be the cipher to the power of D, right? The decryption key mod, oops, N. Okay. All right. So return K. So now we can go over here, and we know that encrypt RSA takes message, which is M7, and then it takes E and N. So we've got N already, N, which is P times Q. Now in this example, I'm giving you the key, so I'm not making you calculate them, right? We'll do that in problem 3, because it's much, it's not trivial. And this will be E, so we need to define E, which is, this is the problem, but I need something easy to implement this, because as I said, these get really big really quickly. What are they? Sure. So these might be exam type problems where I just give you parameters and I just say what's wrong, so just bear that in mind. All right, so that should be everything for that. And then for the decryption part, should be cipher, comma, D, comma, N, right? Everyone with me? That should be it. So go ahead and run it, right? And so it's 7, and then the decryption value should be, yeah, and then 7 again. Oh, I forgot right. So I need to give this the cipher, comma, D, comma, N. And down here, they're already there. Oh, yeah. And there you go. That's it. As you can see, this works, right? That was easy, super easy, right? That's problem 1 of your homework. Just please do this. Show me this screenshot, that you did it, okay? Should be pretty straightforward. I'm recording it. Follow the recording, please. All right, problem 2. It's now unrealistic numbers, right? But as we saw in the, they're too small, but as we saw in the when we did this in lecture, one of those gets really big. Do you remember? I don't know if you remember that part. So try it and see what happens. Okay. Again, remember, these are totally insecure numbers, right? Our prime numbers need to be much bigger. Does that make sense? So now we did problem 1. So now go ahead and try to solve on your own problem 2. And if you find difficulties with this, you need to think about it. Okay. Yeah, and it's 5:20. So as I said, just work on this for the rest of class. This homework is not due yet. I do want you to complete all 3 problems. I remind you, Tuesday, no class, full break. And then Thursday, we will do this problem, which is much more involved. And it's already posted, I should say, if you want to start reading through it, the code is already posted on here, and you can see it right there, this PY file. That is RSA written from scratch, no libraries, no anything. And it's got all the relevant algorithms. Any questions? Henry, do you have a question? What? Do you have something you want to say? Good. You're going to talk about elliptic curves? No joking. Was that your joke last?
Oh no. So I think last time I asked a lot about it, and at the end, no one didn't want to elliptic curves, so we had to choose something else.
Okay. Nice. So just use this code that I gave you and change the parameters, right? And try it. Yeah, go ahead. Yeah, sure. Yeah. This code should be on the GitHub. Which part? Okay. I'm gonna pause the video because we're not doing anything.